Hi, I'm glad to have the chance to speak in front of you today and to show you one of my recent projects. But before we begin, I would like to shortly introduce myself to you. My name is Igor Czyrski and I'm a software quality engineer for a nice project company. I have not always been strictly involved in the IT industry. I started my career as an automation engineer. I've been involved with projects to improve the production process by implementing automation and robotization. Mostly I was projecting automatic production stations. I've programmed robots and PLC controllers, but when my work began to focus on leading projects, I decided that I would rather focus on the technical aspects. Programming was always something I was interested in, so I became a Python programmer. I've been a software developer for about a year, but I've quickly realized that my personal traits could be useful in helping developers to deliver robust and reliable software. That's how I became a software quality engineer. During my daily work, I use Python, RobotFramework, Ranorex, CI/CD pipelines, Docker, and many more, depending on the actual client needs. Okay, so let's start from the beginning. What means RPI in the title? It is possible that some of you have not yet had to deal with this kind of software. RPI means robotic process automation. This approach involves usage of software to replace digital, tedious, and repetitive tasks. It can be integrated with both the backend, such as application databases, or the frontend and desktop connections. It's gaining more and more popularity recently, so there are a lot of commercial as well as open source solutions. An example of such software is the previously mentioned Ranorex. Ranorex is a low-code, no-code solution for automation of web and GUI applications. As the title says, today we will focus on automating tasks performed on the web with a robot framework. I will show you how I've managed to automate gathering Splunk's charts, but before we get to the technical part of the presentation, we need a brief introduction to the problem. I divided this section into the three main parts. Firstly, I want to show what is the Splunk in general for those who have not yet had any contact with it. Then I will describe how my work used to look before I started working on the solution. And finally, I will tell you what were my main goals for the project and how I visualize it in my mind. Let's go. So, what is the Splunk? Splunk is a software that helps to capture, index, and correlate real-time data in a searchable repository, from which it can generate graphs, reports, alerts, dashboards, and visualizations. It is mostly used for application management, security and compliance, or the web analytics. Of course, its applications are much broader. Splunk is a well-known tool used by many hefty companies around the globe, and it is held in high esteem. For my purposes, it is used to collect performance data to then analyze and interpret it. But let's take a look at an example of the sample graph generated using Splunk. This is the actual graph that I've downloaded from my test environment. It shows the disk activity, the percentage of elapsed time that the selected disk drive was busy by reading or writing the request. This graph is one of the less complex ones. It shows only 3 types of data, one for each disk. But throughout the presentation, I will show you more elaborated examples. Okay, so now when we know what Splunk is, let's take a look at how my work used to look before my solution. Generally, we can divide this process into 3 main steps. First one is strictly connected with the Splunk itself. To gather screenshots, a couple things need to be done. Of course, at first we need to log into the Splunk. Then we need to prepare and provide arguments on the basis of which the graphs with data will be generated. Those arguments are time frame, as a day, month, year, or the period between two date times, and the server or the machine which will be the source of the data. Then we have to go through all of the generated charts and analyze them. We need to focus not only on the overall chart, but we need to be meticulous on a single process line. I will show that in a second. During or after that, we need to gather screenshots of all the summary charts and all of the process lines that concern us. Of course, gathered screenshots need to be secured, packed, and transferred to the right place related to the Jira ticket. And the final step is report preparation. It all sounds so clear, but let's talk a little about the weakness of this approach. Splunk works on a huge data sets, very, very huge ones. Due to that, its responsiveness can sometimes be disappointing, and switching between charts, and we do it a lot, can take up to 30 seconds. This means the whole process of gathering the screenshots can take up to 1 hour. Also, the taking screenshots by hand is tedious and simply boring, which means that mistakes can happen. And what's the most important about this process, this is the manual approach. So it makes a bottleneck on the test automation process. So now, when we know the cons through the manual approach, let's jump into completing the goals and projections. Okay, so what did I want to achieve? I wanted to create a library ready to be used directly from the command line. I decided that I want to write it as a RobotFramework tasks extended with the power of Python. And of course, I wanted to make screenshots gathering fully automatic. I will show you the reason why there are two types of the screenshots listed below. Let's look at the graph, which I've shown you before. Again, it's the disk usage over time. Summarizing the chart, on the top of this slide, we can see three data sets overlapping each other. It's hard to clearly read and understand any of the information without analyzing it in more detail. But that is where Splunk offers us the possibility to focus on a single graph at a time by focusing the mouse pointer on the graph label. Thanks to that, the graph can be divided into three separate graphs like in the pooled datasets beneath. If we have only 3 targets, it's not such a big deal. Let's see how it will look like with more of them. In this dataset, we can see a graph with more than 30 processes in it. Now it's almost impossible to even see a single process. In my line of the work, most of the graphs that I need to analyze look exactly like this. And of course, due to that, I didn't want to have a single screenshot of a summary chart. I wanted to have each of the process or disk to be on a separate screenshot. Also, I wanted to generate a summarized report, which will be ready to attach to the final report, Jira ticket, or other test report metadata. I wanted to achieve 2 approaches of application usage. First one, triggered manually by the user directly from his console. The second one, which allow us to fit it into the CI/CD pipelines. And of course, one very important thing, at least from my point of view, ease of installation, usage, and overall satisfaction of users, which are my team members. It's always a good idea to maintain good relations with colleagues. My solution is based on several technologies. Of course, RobotFramework and Python. Communication with the website will be done using Selenium. Selenium will be supported by Selenoid, the Golang implementation of original Selenium hub code. It is using Docker to launch browsers, and for us it allows to execute applications on the Gitlab runner machines. The user doesn't have to run code locally. Instead, he can send his order to the designated machines. The application is packaged into a Python library via Poetry. And as the application needs to be executed automatically, also Gitlab CI/CD pipelines have been used. To present to you the solution, I have decided to focus on a series of major elements and tasks of the program. We will go through the structure and flow of the application. I will show you how the application is packaged, how it is installed, and how it should be used. And of course, at the end, creme de la creme, the sweet and tasty results. The project structure can be divided into two main parts. The first one is the operation of the application itself. The main PY file is the script that oversees the library. It prepares the input arguments passed by the user, it formats them, and most importantly, runs the robot tasks. Robot tasks files import Python libraries, variables, and robot resources. The second part is the part responsible for deploying the library. I'm talking about YAM with the Gitlab CI/CD definition. After past unit and integration tests, as well as satisfying a couple of other requirements, library is packed as defined in Poetry toml file. Okay, it's time to say something about general flow of the application. Library is prepared for the two kinds of provided inputs. The first one assumes that the user wants to manually define the date times between which data will be gathered. The second one points to the robot report log file. The file will be analyzed to extract the start and end times of the test. Thanks to that, the application can be piped with the actual tests and collect information from their time span. As was mentioned, the main file prepares the library to start robot tasks. It detects manual and automatic run. If the program is run by the user locally, in the CLI, it will ask user to provide the Splunk username and password. Before gathering the charts, the data sets need to be provided for the data driver. Using the application configuration and Python functions, relevant XML files are created. Why are there two kinds of tasks? There are two types of charts. Charts with the number of processes allowing to be shown on a single view, and charts containing so much processes that they have to be divided into 4 separate views. It can be seen on the screenshot attached on the right. There is a drop-down menu where you can choose which part of the data you want to analyze. After gathering the screenshots, the summary HTML output file is generated. From now, it is ready to be attached to the test report metadata or Jira tickets. This is the code of one of the tasks. I will not focus on the code at all, but I just want to show you what it looks like. Packaging and installation. If you want to modify the library, you need to create a fix branch, a feature branch in general. Changes are pushed out to the package repository manager only after the branch is merged into the master branch of the project. Before that, during merge request, code is not only reviewed by one or more of the teammates. It must satisfy a couple of requirements. It must be checked by the static code analysis tools. Integration and unit tests need to be passed, and the documentation needs to be generated. This way we can reduce the risk of defects in the library. The library is stored in the internal repository manager, Nexus in my case. It can be downloaded and installed like any other Python library using a standard pip package installer. How to use this solution? I think that's quite easy. The application can be started just as any other Python library. Depending how you want to determine data gathering timeframes, you can call it in two ways. The first one, using start time and end time flags. This approach requires to specify manually the gathering timeframes. The second way points to the RobotFramework report log file from which gathering timeframes will be taken out. If user is starting the library in his CLI, he will have to manually provide Splunk's username and password. But in the case of using the library with the help of CI/CD pipelines, an automatic run will be detected and the username and password would be determined from the CI/CD variables. As a result of the program, we've got the final outcome folder with the structure that you can see on the left part of the screen. There are folders with the charts without the labels mentioned before. So the folder contains screenshots directly. And there are folders containing subfolders for each of the processes group. And screenshots are gathered in those subfolders. Overall, in my case, more than 20 folders and over 400 screenshots are collected each run. The HTML summary file generated at the end of the library run embeds summary screenshots and basic run data, e.g. the server from which data sets are gathered or the time frame of the gathered data. If the library is used during the pipeline, the results are stored as artifacts. As you have seen, the solution is not complicated or sophisticated, but it allows me to save a lot of time and nerves. The process, which take up to 1 hour of tedious attention requiring work, can now be run in the background and I have the time for a coffee. Other important tasks. Results of the work are more consistent as they are gathered by robot. Every screenshot is in the same size and it is formatted the same way. The risk of making a mistake has been eliminated. The biggest benefit of this solution is the ability to react quickly for the requests of analyzing something. Let's say that the client suspects that one process causes memory leakage. They have asked me to check that. With my tool, I will have the results in a short time and with little to no effort. Perfect. And that's pretty much I wanted to share with you. Thank you very much for your presence and attention. If you have any further questions or queries, don't hesitate to contact me. See you soon.